All right, so for each of these, you have to start with what is sometimes the hardest thing to do, which is just to make a decision about what method you're using. Step one in that process is always looking to see, can you divide every single term by the same thing? In the case of the first one, no, you can't. And so then I see that I have x squared and then x. And so I'm going to go ahead and factor it using the new method that we just learned, which is set up two parentheses. Each parenthesis starts with an x. And then I want to figure out what are the two numbers that add to the middle number, which in this case is negative 15, and multiply to the last number, which in this case is 56. And so you think about your multiplication tables and you think about, okay, what multiplies to 56? And you end up getting 8 and 7. Because that does actually add to 15. But notice I need to multiply to a positive but add to a negative. That tells me that it's got to be a minus and a minus. And so we'd end up with x minus 7 times x minus 8. Or, if you wrote it as x minus 8 times x minus 7, that's still fine. You can change the order of the parentheses and it still equals the same thing. All right, going next to it, x squared minus 9. This is one of those cases where you're going to have to end up with the same number and just 1 plus, 1 minus. So it ends up being minus 3 and plus 3. Or plus 3 minus 3. Again, order doesn't matter there. Because that's the way that they can add to 0, because you notice the lack of an x in the middle there means it's a 0x, and multiply to negative 9. All right, the next one over here. You actually have a couple options you can use for that. You can just say what adds to the middle number and multiplies to the last number. Or you can recognize that this follows the pattern that we had actually learned before yesterday's lesson. And you can see that if I divide that middle number by 2, it gives me negative 7. And negative 7 squared equals 49. That tells me it's going to end up with x minus 7 squared. Now if you just did what adds to the middle number and multiplies to the last number, that's fine. But if you wrote it as x minus 7 times x minus 7, it's correct as far as it goes, but I do need you to clean it up. I do need you to actually write it with the squared there as a way to make it just that little bit more succinct.
For what?
All right, and then for the last one, we again look to see at the very start there, can I divide every term by the same thing? Well, I can't divide them all by the same number, but they all do include x's. So I'm going to go ahead and factor out some x's. How many x's can I factor out there? 2. So I'm going to factor out the x squared out of every. When I do that, this is what I end up with. Now, some of you might be wondering, wait, can't we factor this though? Because there are two numbers that add to 15, multiply to 15, but add to 8. That's true, but we can only use that method. We can only do the add to the middle number, multiply to the last number thing if it goes x squared, then x, then number. Since that's an x cubed, it doesn't work here. Now as you take a look at this, hopefully you're remembering the process. If not, it's a good reminder then. First thing we want to do is we want to get whatever squared by itself. So notice that means I got to get rid of the 4 first. So we add 4 at the very start. Now that I have this squared by itself, I can now get rid of the squared. What do we do to undo squared? Square root. Exactly. Now, there's one little detail here. When we actually take the square root of both sides, what do I need to remember to include? Yep, that plus or minus. Because there's two different ways that we can square a number to get 25. Both a positive 5 and a negative 5. That's the critical piece of this to remember. All right, so now that I've square rooted both sides, remember square root cancels out the squared here. And so I now need to write out what this looks like though. But I don't really want to write it out as x minus 7 equals plus or minus 5. No. That doesn't look quite right, does it? So because this is awkward to work on. So we write it as x minus 7 equals 5 and x minus 7 equals negative 5. Yep. Then once we've written both of those equations, we solve them out from there. If you had any trouble in solving this through, a little bit of forgetfulness or something, whatever, just make sure you have it written down so that you can reference back to it later. And this is really a great foundation for the work we're going into today, because this type of problem ended up with two solutions, and we're going to be taking a look at another type of problem that can give us two solutions. We're looking at absolute value equations today. So go ahead and write down this equation, the absolute value of x equals 5. Now we could solve this before today by graphing it, right? Like you could graph the absolute value of x, that would be a v. You could graph y equals 5, that's the horizontal line. And we could look to see where do they intersect, and we could get our two answers from there. But notice, there will be two answers. Well, if we take a look at our equation over here, we're saying the absolute value of what must equal 5? Well, the absolute value of 5 certainly equals 5, right? But also the absolute value of negative 5 will equal 5. And so just like with our quadratics, we end up with a plus or a minus. That's basically how you get rid of the absolute value bars, is you do a plus or minus to both sides. This one's the same basic idea. And there's a lot of overlap with this and our quadratics. The first thing you want to do, get the absolute value by itself. So, get rid of the 7 from both sides. Once you've done that, we now have 2 equals the absolute value of x. Alright, now how do we get rid of the absolute value bars? Well, we account for the plus or minus, yeah. And so, in order to get rid of the absolute value, we then do whatever was inside x equals the plus or minus of that same number. So it equals plus or minus 2. So x equals 2 and negative 2. Remember, you can give your answer either way. You can write it as plus or minus 2, but slightly better form to write 2 and negative 2, partly because it's a little clearer, partly because it's more useful in the more complicated ones, and partly because that's how you have to do it on WAMAP anyway, so you might as well make a good habit of it. All right, next problem. 3 times the absolute value of x equals 21. Again, the very first thing we need to do is get the absolute value of x by itself. That means getting rid of the 3. What can I do to get rid of the 3 here? Yep, we divide. Exactly. All right, and so the last thing to do is get rid of the absolute value bars, which results in the plus or minus. So x equals 7 and negative 7 here. Now for the last one, for number 4, the first thing I suggest you do is combine like terms. Anytime you can simplify on one or both sides of the equation, do so. And so, I do the 42 minus 36, and I do the 14 minus 29. Then I can go ahead and isolate the absolute value of x. And then once we have the absolute value of x by itself, then we go ahead and we can get rid of those bars. And so, you should have found there x equals 21 and negative 21. Now that we've seen how to do those, we can now start dealing with the ones that add a little bit of more complexity. So, write this one down. So normally the very first thing we have to do is get the absolute value by itself. Well, the absolute value is by itself here. Can we subtract the 5 from both sides then? No. Because the plus 5 is trapped inside of the absolute value bars, I can't just pull it out of there. So instead, I have to get rid of the absolute value bars first. Well, we already know how to do that, right? That's where we end up with the plus and the minus. The only thing is here that writing it as x plus 5 equals plus or minus 9 is not going to be especially useful. Because notice I'm going to have to still be moving that 5 over. This is like that quadratic we did earlier. Rather than writing it as x plus 5 equals plus or minus 9, we write it as x plus 5 equals 9 and x plus 5 equals negative 9. We split it into the two separate equations. Then we have two equations. We can actually solve them through from there. So we can go ahead and subtract 5 from both sides. And so when we do so, we can then see here in this example that x equals 4 and x equals a negative 14. All right, so just like the problems that we worked on earlier in class, you want to start by getting the absolute value bars by themselves first. And so I'm trying to isolate that part, which means getting rid of the 2, getting rid of the minus 5. First thing I want to do is get rid of the addition and subtraction always. So we add 5 to both sides. Then you can get rid of the 2. That's 2 times the absolute value. So divide both sides by 2. Now that we are here, we get rid of the absolute value. This is the critical piece. This is the new piece from today. In order to get rid of the absolute value bars, split it into the two equations. One of them equals 6, the other one equals negative 6, and then solve from there. And so, in order to solve each of these, notice that means adding 9 to both sides. So we end up with final answers of 15 and 3.